All right, let's talk about one of the biggest, coolest challenges in AI right now. We're trying to make it learn more like us, incredibly fast, and from just a tiny bit of information. Today, we're going to dive into exactly how researchers are trying to make that happen.
Okay, let's try a little thought experiment to frame this. Imagine you want to teach a computer to recognize a bird it has never ever seen before. How would you actually do it? Well, the answer turns out to be way more complicated than you might think. Because right now, for a top-of-the-line AI to learn what that new bird looks like with any real accuracy, get this, it would typically need to see over 1 million images. 1 million! I mean, that's just a crazy amount of data for one new concept. And that right there just perfectly highlights the massive gap between us and machines. You or I could see one single photo of that new bird and bam, we probably got it. We'd recognize it again. That ability to learn from almost nothing, that's the holy grail for so many AI researchers. This massive appetite for data is what we can call AI's billion photo problem. And it's not just that it's inefficient, it's a fundamental bottleneck. It stops AI from being useful in all sorts of real-world scenarios where, you just don't have a giant data set lying around. And hey, don't just take my word for it. The paper this whole explainer is based on, a big survey from 2023 on this topic, puts it bluntly. The success of deep learning is totally built on these massive data sets that are incredibly hard and super time-consuming to put together. So, how in the world do we solve this? Well, the answer lies in this really fascinating shift in thinking. We need to teach AI not just what to learn, but how to learn. And this whole approach is built on two core ideas. First up, the goal. It's called few-shot learning, and it's pretty much exactly what it sounds like. The big idea is for an AI to be able to learn a whole new category, like our new bird, from just a tiny handful of examples. We're usually talking between 1 and 5 shots or pictures. And the strategy to get there is meta-learning. Now this is the really cool part. Meta-learning is basically learning to learn. So instead of training a model on one giant task, you train it on a huge variety of smaller learning tasks. It gets good at the process of learning itself. So you might be asking, how does an AI actually learn to learn? Well, researchers have come up with 3 main strategies to make this happen, and each one has its own pretty clever way of looking at the problem. First up, we have what I like to call the comparison game. Think of it like playing a game of spot the difference. The AI isn't trying to learn what a bird is in some absolute philosophical sense. Nope, it's learning a universal skill, how to judge the similarity between any 2 images. A classic way to do this is with something called a Siamese network. The process is actually super elegant. You feed it 2 images, 2 identical networks look at each image and pull out their most important features. Then, a final layer just spits out a similarity score. So instead of learning bird, the model is learning a universal metric for comparison. A high score just means the 2 images are probably a match. Simple as that. All right, our second approach changes gears a little bit. It's not really about comparison. It's about building a model that's designed from the ground up for speed, one that can absorb new information almost instantly. Yeah, the whole idea here is to actually tweak the model's architecture. Some models, like memory-augmented neural networks, are built with an external memory. You can literally think of it like a computer's RAM. So when it sees a few examples of something new, it learns how to write that info into its memory and, crucially, how to pull it back out later. It's like giving the AI a super efficient short-term memory to handle new concepts on the fly. And that brings us to our third approach, which is probably my favorite analogy. Imagine you're about to run a race, but instead of starting at the beginning, you get to start right next to the finish line. This method is all about finding that perfect head start. So what this means is, instead of starting with a totally blank slate with random settings, meta-learning is used to find an initial starting point that is already incredibly well positioned to learn any new task. It's not an expert at any one thing yet, but it's really, really close to being great at everything. And the result? Well, when a new task comes along, the model only needs a couple of tiny little nudges, a few small adjustments to become an expert. The prime example here is an algorithm called MAML, which is famous for being incredibly good at finding this optimal starting point. Okay, so let's do a quick recap of those 3 big ideas. We've got the metric-based approach, our comparison game, then there's the model-based approach, the fast-adapting model, and finally, the optimization-based approach, which gives the AI that perfect head start. Each one is a different path but they're all leading us toward a faster, more human-like AI. Now, as exciting as all this sounds, meta-learning isn't some kind of magic bullet. At least, not yet. The field is still developing, and researchers are grappling with some pretty significant hurdles.
And these challenges are very real. For one thing, while it uses less data for the final task, meta-learning itself needs a huge number of diverse training tasks to learn from in the first place. There's also no single best model. Some just work better for certain problems. They also really struggle when a new task is super different from what they were trained on. And finally, like a lot of neural nets, they can be a total black box, which makes it a nightmare to figure out why they make the decisions they do. So where do we go from here? Well, researchers are focused on tackling these challenges head-on. The big push right now is to create models that can generalize better, especially across different domains. Like learning from cartoon animals to then recognize real animals, and even across different types of data, like images and text combined.
Which brings us to a final thought. We're moving from AIs that need a million examples to ones that might only need one. And that raises a fascinating question for all of us, doesn't it? If we get there, if an AI can learn almost anything from a single example, what's the very first thing we should teach it?